Hey folks, in this lecture we are going to review some information from CSE 1321. Specifically, we're going to talk about variables, primitive and object variables. We're going to talk about reading and write statements, and we're going to talk about if statements. And then we're going to have follow-up videos for different topics beyond that. So the first thing we're going to talk about today are variables. And hopefully you guys have used variables a fair bit in 1321. So there are two different kinds of variables. What we call primitive variables are variables that are native to the language, and they are just inherent. So you have bytes, shorts, longs, doubles, floats, and characters, spelled out as CHAR. If you are in a C# world, then bool is the way that you write a boolean. If you're in the Java world, then you actually spell out the word boolean. In both cases, you can type capital string, capital STRING for a string, if you're trying to do a long set of characters. Okay, so let's talk about the differences between each of those and why they matter. So most of the time, if you're using a number, you're going to do an integer if it doesn't have a decimal place and some numbers after it. So for example, if you say 2 plus 4, the answer is 6, all of those are integers. But if you say 7 divided by 3, then the answer is no longer an integer because it has a decimal point at the end. So in those cases, you're going to want to use either a double or a float. And both of those are considered floating point, and they have the ability to hold numbers past the decimal point. If you know that you're doing something that's very short, a very, very small number, you can use a byte or a short instead of an int. And if you know you're dealing with very large numbers, like let's say about greater than 4 million, then you might want to use a long in those cases. The difference between each of those is just how much memory it uses in order to store the information. So you should pick the one that's appropriate to what you're doing. For example, if you're only ever going to store the numbers 0 and 1, then you should probably store that as a byte. If you're storing numbers that are huge, then you need a long. But don't always just use a long. Don't always just use a byte. Pick which one is appropriate for what you're doing. Likewise, in float and double, a double can hold double the precision of a float. Therefore, it can hold much bigger or much more precise numbers. Characters hold a single character. So if you're going to store a character, then you're going to do it as a char. And the way that that's going to look is you're going to say something like, that is not working. Let's try that. CHAR. And that's going to be in lowercase. You're going to give it your variable name, which I will call it X in this case. And then, for example, if you're wanting to store the letter A, you would do it like that, where you have single quotes around it in order to indicate that it is a character. If you don't put those single quotes in there, it's not going to work out. So those are super important when you're defining a character. They are different from double quotes. If you have double quote A, then it's assumed that you're dealing with a string. So single quotes imply a character, double quotes imply a string. So you should keep that in mind when you're doing that. In your lab this week, you're also going to have a slight weirdness, which is occasionally you're going to need to, for example, make a character that is a single quote. And what I mean by that is I might want to define char y equals, and I want it to just be a single quote. Well, how do I do that? Because, as I said, you have to wrap your character in single quotes. So that would leave you with single quote, single quote, single quote. And if you type that into a compiler and try to compile it, that is going to produce a syntax error. Actually, very specifically, the error is going to happen right there on that third one. Because what it looked at is the first two quotes, and there was nothing in between them. And then there was a third quote that didn't make any sense to it, so it's very confused. So the way that you have to do that, and this is specific to any kind of special character that you're dealing with, is you would do single quote, and then you use a backslash, followed by a single quote, followed by a single quote. And I ended up with an extra one. All right, so what is all that nonsense, and why would I ever have to do that? So let me just draw some circles around the different bits here. What I'm doing is the outer single quotes, which I will point to in blue here, those are what delineate the character. So I'm saying that this character is inside of those two single quotes. What I put inside the single quotes is a backslash, which is the character that is above your enter key on your keyboard on the right-hand side. It is different than a forward slash, and then a single quote. What the backslash character does is it says everything that follows this is merely going to be treated as if it's a literal character. So don't think of it as the special single quotes that you're using around a character. You're just literally seeing a character here. And so that's how you would get that to compile. You'd have to put that backslash in front of there. That escaping is what that's called, this method that we're doing right here, where you have a backslash followed by something. That's going to be relevant if you're trying to do a single character that is like double quotes, or if you needed to do one that is sometimes parentheses can confuse the compiler, sometimes curly braces can confuse the compiler. Anytime you're using something that's like goofy, that has a meaning to the language, then you'll sometimes need to put a backslash on front of it. That'll help you just get through things. The final one I'll mention is if you're trying to do a literal backslash as a character, then that would be we'll do z equals, and it's going to be single quotes again, and then this time we're going to do backslash backslash, because the first backslash says the next thing is a literal thing, and the second one is just a backslash. So hopefully that makes sense. All right, so that is how you define a variable. In both Java and in C#, you're going to put the type of the variable followed by the name of the variable. Optionally, if you want to, you can go ahead and give it a value at the same time that you're doing it. So it's perfectly valid to say int my number, semicolon. You can also say int my number equals 42, semicolon, and that of course initializes it at the same time that you're creating it. If you're looking at this last one down here, you might wonder why there's an F at the end. And the reason for that is sometimes you need to specify that the value that you're putting in is specifically to be treated as a float. In this case, it's relatively obvious because you're doing 0.65. But if you're trying to take in the number 7 and you're going to do floating point operation math on it, like you're going to divide it by 3, then you might need to say 7f divided by 3f in order so that it understands that we are doing floating point math, not integer math. It will default to integer math if there is no f on there. And so sometimes if you do 7 divided by 3 and you don't specify f on both sides of that, you'll get a weird answer, which is 2, which is not actually the correct answer. And it's because it did integer math, not floating point math. So something to keep track of there as well. All right, so that's how you define variables. You're going to do this all the time. Variables typically have a scope. Their scope is whatever particular wrapper that they're in. If they're inside of the main method of your program, then they're going to be only available in the main method. If they are inside of an object, then they're going to be available to that object, depending on whether you set them as public, private, or protected, or whatever else you may do with them. You specify the scope to which that variable is available. But typically, variables are only in existence inside of their surrounding curly braces, whatever that might be, whether that be that method or that class. Okay, so the next thing we're going to look at here real quick is how you read information in from the user and how you print information back out to the user. Again, probably a review for most of you guys. If you are in C#, you're going to use console.write or console.writeLine. Console.write does not do a carriage return at the end, meaning it doesn't hit enter and bring you to the beginning of the next line. It just outputs whatever you tell it to output, and then it waits for you to do something more. Whereas a console.writeLine, after it outputs whatever you tell it, it automatically puts a carriage return in and returns you to the beginning of the next line. So depending on what it is you're trying to print, if you want it all on one line, you might have multiple console.writes and then one console.writeLine at the end, or you may have a bunch of console.writelines, which will have them come out in a column. If you're reading in C#, super simple, you're going to have a console.readLine, and that's going to be assigned to a string because it always gives you back a string. If you want it to be something other than a string, you're going to have to do a parse on it. So, like for example, if you're reading in an integer here, you're going to say something like int32.parse and then console readLine. And what that does is it does the same thing as before. Console readLine will pull in one line from the user, but it then sends it to the parse method inside of the integer wrapper. And what that's going to do is it's going to look at the string and try to pull out the integer out of there. There are similar methods for doing that if you're trying to pull out a floating point number or you're trying to pull out something else. But this one is actually probably the most common one because you're building some form of a menu and you want the user to type in a number between 1 and 3 or something like that. Then you're going to want int32.parse. Okay, so that is how you do it in C#. If you are going to do it in Java, then you're going to have either system.out.print or system.out.println, and that's the same thing as we just talked about in C#, meaning that print will print and not do a carriage return, println does a carriage return. The input in reading input from the user in Java is a little bit more complex. You're going to have a couple of lines in here. You're going to define a new object called scanner. So it is going to be a variable of type scanner, and that is an object type. You're going to give it a name, which in this case they called it scan, but that can be anything. It can be Bob, Fred, Mary, X, whatever you want it to be. And then that's going to get a new scanner. This is how you instantiate an object, and we're going to have a whole other section about that in a couple of days. But scan gets new scanner, and then you are always going to pass it system.in, which is effectively the keyboard for all intents and purposes. So you're telling scanner to read from the keyboard. Much later in the class, we're going to deal with file IO, and you're going to use a similar thing, except instead of system.in, you're going to read from a file. So that's why you have to specify where you want it coming from. But for most of the time here, you're going to be reading from a keyboard as the user types in. Once you have it, then you're going to call next line on it in order to actually get back a line. If you're trying to pull in an int here, it's a little easier than it is in C#. You can say next int instead of next line, and it will pull in the next integer. There are other options, and you can certainly look those up in the documentation of the scanner object. So just Google Java scanner, and then you'll find all of the methods that it supports, next line, next int, and so on and so forth. All right, so that is reading input. All right, and the last thing that a couple of thoughts here. If you are going to read an input from a user, we're going to assume that they're giving you the correct data type as far as this class is concerned. So in the real world, when you ask the user to type something in, you have to assume that the user is insanely bad at doing this. If you ask them to type a number between 1 and 3, assume that they are going to type in X, because that's what users do. So in the real world, you actually have to check for that condition and figure out what's going on and make sure that you are correctly typing you're checking the type of what's being entered from the user. But we're not really going to require you to do that unless we specifically specify it. So you can assume if you ask the user for an integer, you're safe to just parse int and then see if you get an integer. And if you don't, well, life goes on. So later in the course, we will talk about how to actually do exception handling, but until we talk about that, which is I think week 7 or so, we're not going to hold you to that. All right, so you might ask the user to enter in a name, and then you might read in a name, and then you might say hello to them. The one thing that's new here, so the console.write, that makes that appear on the screen, what is your name? And then it's going to sit here and it's going to wait until they type in an answer because of this console.read line. Specifically, it's going to wait until they hit carriage return. So when they can type whatever they want, and then once they hit enter, whatever they had typed is going to be stored in a variable called name, which is of type string here in C#. And then we're printing out again to the screen and we're saying hello plus name. All right, so this is how you access a variable. Think of the variable as a bucket. Once you created it up here, it's a bucket that has nothing in it. When you did the console.read line, the user typed in some information, they hit enter, it gets put into your bucket. Now you have that bucket for as long as it's valid, you can pull information back out of that bucket or change what's in the bucket. And so at the moment, the bucket contains somebody's name, theoretically, because that's what we asked them to type in. So by doing a console.write line and doing a plus the variable name outside of the double quotes, we're able to print out that particular name. So for example, if they had typed in Enda, it would say hello Enda. If they typed in Bob, it will say hello Bob. And if they typed in XY273, it'll say hello XY273 for no apparent reason. All right, so the important part here is this plus operator. The plus operator is how you add two strings together. This is not mathematical adding, it's just shoving two strings together. This technically is a string, because remember I said if there are double quotes around something, we're treating it as if it's a string. So technically there's a string called hello, and we're concatenating to that string the word name. And we did put a space in here, so it's actually the word hello, followed by a space, followed by the name, and then when that gets sent to this console.write line, poof, out comes the name. So hopefully that makes sense. This plus operator is the same in C# as it is in Java. It's how you concatenate strings together. So this is the exact same code. You would have had to say name, scanner, name gets new scanner up ahead of this in order for this to work. All right, so One other thought here is for this class and this class alone, when you're writing your tests, you are welcome to use the word print instead of typing out system.out.println, and you are welcome to use the word read instead of typing console.readline. And I intentionally did that for 2 different languages because that is true in both languages. Regardless of whether you're Java or C#, you can just use the word print in any test, or you can use the word read in any test, so you don't have to memorize that. When you're writing code, obviously you actually have to write them, but on the test, we'll accept either one. All right, and then the last topic that we're going to cover in this little video is we're going to talk about if statements. So an if statement allows you to do something depending on some other input. So in this pseudocode example, we're asking somebody for their age, we're reading in their age, and if the age is less than 18, we say you can't vote or drink. If it's less than 21, then we're going to say you can vote but can't drink, and otherwise we're going to say you can vote and drink but don't vote shortly after drinking. Okay. There's probably lots of comments to be made about that last statement this week. But anyway, moving on. If age is less than 18, then this first part of the if statement will happen. So if they give an age of 16, what actually happens is 16 gets filled in here, and we evaluate 16 less than 18. That is true. Since this evaluated true, we are going to do the first part of this. We are going to do that print statement. If they gave us the number 19, it will again fill in 19 in here, and it will evaluate 19 less than 18. That is false. When an if statement evaluates to false, it's going to skip down and see if there's an else if or an else. In this case, there is an else if, so it's going to do the same test on this line. 19 less than 21, that is true, so now it's going to print out this statement and go to the end if. So in an if, else situation, it will only do one of these lines. It will never do all of them. As soon as one of them works, it's going to jump to the end if. So if they give us an age of 16, it's going to do the first line and then jump to the end if, and it'll continue if there's anything down underneath here. All right, so let's look at this in C# and Java. Actually, the code is going to be pretty much identical if we ignore print and read. So print, how old are you? We read in an age. If the age is less than 18, print this. Otherwise, if it's less than 21, print that. Otherwise, print this. So let's talk about the else, because we didn't talk about that. So if they give us an age of 23, 23 less than 18 is false. 23 less than 21 is false. So then it goes to the else. Since there's no other condition here and there is an else, it will just do it. You don't always have to have else ifs, and you don't always have to have elses. It is entirely valid to have an if statement that just has an if statement with nothing else, with no else ifs or else underneath it. The other thing to note here is that there are no curly braces in this code. And honestly, I don't really love that. Most of the time, I would encourage you to just put the curly braces in, but let me explain the rules. If after your condition, which this is the condition, the thing that we're testing, if after the condition there is only going to be one line of code, then it is permissible to not put in curly braces around that one line of code. If you have more than one line of code, you must put in the curly braces, otherwise it will interpret incorrectly. The same goes for the else if, and the same goes for the else. So this is valid code, and it will actually work. I mean, other than the fact that the word print is in there. But I would encourage you to just always put in the curly braces. They are not strictly necessary if you only need one line, but I just feel like it makes it a lot clearer what you're doing. And you will probably have less errors in life if you just always put them in, because often you will start off with only needing one line, and then you'll have to go back and change it, and you'll add a second line, and all of a sudden it will give you a syntax error, and you'll be confused why, and you'll spend a lot of time trying to debug it. Had you just put in the curly braces, it would work either way. All right, so that is the end of the if statement. So I'm going to do a quick example over here. So this is Replit, and as I've mentioned in lecture before, Replit is really handy because it allows you to just do a very quick set of code. So in this case, I'm typing this in Java. I will come back and I will do it in C# in just a moment. All right, so what are we going to do here? I'm going to, first off, I'm going to ask the user to pick a number. So I'm going to say enter a number. All right, and I'm going to read in a number. So I'm going to say scanner, I'll call it x equals new scanner system.in, and then I'm going to x.next int, and I'm going to store that in a variable called guess. So int guess equals next int. Okay, so theoretically, and I'm just going to print that out so that we can all see what's happening here. So I'm going to go ahead and run that. And let's see what happens. Hopefully it'll ask me to enter a number. The compiler is not the fastest thing in the West, but here we are. I can't find symbol system.in, and that's because it's a capital I. Okay. Okay, forgive me. That is not a capital I. I don't know why I thought that was. And the problem here is I need to import scanner. So I'm going to import java.util.scanner. And the other thing is when I'm printing this out, I should be printing out the guess, not the scanner object, because that's not what I'm trying to do here. All right, so now with any bit of luck, enter in a number, type in the number 8, and it printed out the number 8. Not very exciting here, so let me just change that a little bit so that you can see how that works. You guessed, and then we're going to plus the guess variable. Okay, so what that's going to print out now is you guessed, and then the name or the variable that I typed in, which is my actual guess. So I type 6, and it says you guessed 6. Very exciting stuff. All right, so let's create a little guessing game here. So what I'm going to do is I'm going to create a variable. I'm going to call it answer, and I'm going to set it to the number 10. All right, so we've had them type in a guess, and what we're going to do is we're going to see if they got the answer right. So we're going to use an if statement. If their guess equals the answer, then we're going to system.out.println. Correct. And then otherwise, we are going to system.out.println. Wrong. Very exciting code here. All right, and we're going to comment that guy out so that he is not printing no matter what. Okay, so what's going to happen is it is going to ask me to enter my guess, and then if my guess is the correct answer, it's going to print out correct. So I'm going to guess 6 because I'm an idiot. It says wrong. All right, we're going to run it again. All right, so how this if statement worked, I typed in 6, the scanner read in 6, it stored it in the variable guess because that did next int and it pulled in that 6. So guess is equal to 6 in that case. 6 equal to answer, answer being 10 is false. So it skipped to the else and it printed out wrong, and then it moved on to whatever was below that, which was nothing, so the program ended. If I type in the number 10, likewise guess is going to get set to 10. 10 equal 10 is true, so therefore it is going to print out correct. And so that is how if statements work. If I wanted to, I could absolutely add in a little bit more complexity. And so I'm going to say else if the guess is less than the answer, I'm going to say too low. And perhaps if it is greater than the answer, then I'm going to print out too high. Now, you might wonder, well, why is this else still here? And the answer is the else is now completely irrelevant. It's impossible to ever get there. Either the answer is correct, it's too low, or it's too high. There are no other choices. So I'm going to type in 7, and it says, nope, that's too low. If I run it again, and I type in 15, it should say too high. And if I type in anything else, it'll pretty much do the same thing. All right, so that is the, if I type in 10, it says correct. That is the example of using if statements, reading in information, printing out information. This is the Java code. If you guys are watching this video, which you obviously are, then you're welcome to pause and grab the URL up at the top here in this Replit window, and that example is going to sit out there so that you guys are welcome to use it. And I'm just going to pause for 1 second, and I'm going to show you the equivalent code in C#. All right, folks, and here is the C# version of that code. Very little of this has changed. Obviously, all the print statements became console.writeLine, and then the way that I read in the number is ever so slightly different on these 2 lines here as well, because I'm using console.readLine and I'm using the int32.parse to get it into an integer. The if statement, literally identical, and the way that I set the variable is identical. So out of this video, hopefully what you got is how to define a variable. That's something you're going to have to do a million times. So ints, floats, doubles, chars, booleans, strings, those are very common things you're going to have to do a million times. Make sure you know how to do that. know how to write an if statement, and know how to read and write input. And so that completes this video. Thank you.